Now they were a little outnumbered, and that was because when I cropped it to squeeze it onto a page for y'all, I mean, that was just the easiest way to do it. So, you know, I'm sure it wasn't a big deal, but now with some of these, you could just reverse to the exponential. And if you can do that, that's the easier way to go. So for that number 5, you could do that. And then number 9, since you had the log on both sides, you just reverse logging both sides, and then you just solve that equation. Okay. And then with number 11 here, first you got to do the power property. So the 1/2 becomes the exponent to the x, the 2 becomes the exponent to the 2. And now you can reverse logging both sides and solve the equation. Now, in this case, when you take the square root, you want to do plus or minus but because we're dealing with logarithms here, you can't have a negative in the log, because that would mean you could get a negative by applying an exponent to a positive base. So we have to exclude the -2 solution because it would cause an invalid domain in the original equation. Okay, and then 15, you want to go ahead and use the properties of logarithms, so the power property and then the product property. And once you do that, then you can switch it to the exponential. So 2 would be the base, 5 would be the exponent, and that's what equals the value. And then here, divide by 4 first, and then take the cube root. All right. And then 17 is kind of a similar problem. You use the product property, and then you switch it to the exponential. So understood base 10, exponent 2. And then in this case, you can factor it after you get it equal to 0. And one of these solutions we have to exclude, because if you go back to the original equation, you substitute -20, you'll get log of a negative. All right. And the same thing with number 21, same kind of thing. Now the exponent is 1, base is 2. And then you can again get this equal to 0 and factor it. And then only the -9 is excluded. I reacted initially by circling both of them because I saw them both negatives. But if you go up here, if you put -6 in for x, there's no problem. Okay, and so then 23 here, you got to get the logs on the same side, and then I did a double step here. So when you add the log to the other side, that's the product property. So I just jumped to that step and then switched it to the exponential. The base is 8, exponent's 1. And then in this case, we could once again factor it, and we exclude the -8 because that would not be valid in the original equation. Okay, and very similar with number 27, except you can't factor this. All right, so that means you got to use the quadratic formula. Now, because one of these solutions is probably excluded, it's probably going to be the one that came from the minus square root. You know, and so you can check that, and that's the case. So only the plus square root is the valid solution. Okay, and then 7, you can switch it to the exponential. 19, here when you minus the log, that's going to be a quotient property, so that's why I wrote it as the division. And then switching it to the exponential, 10 to the first equals that. And you can cross multiply here because it's not an inequality. An inequality, cross multiplying can be an issue because multiplying both sides with an inequality, there's an issue with that. But it's an equality, no problem. Now with 13, what might have cropped up is this little minus log. That's actually -1 times the log. So you use the product power property first, and now you have logs on both sides. And then the -1 means the exponent, it's -1, so the reciprocal, and then you cube root both sides and you're done. Okay, and then ln, number 25, same kind of problem, it's ln instead of log. So product property, and then you switch it to the exponential, which means you got to use the base e. And then when you go ahead and get your quadratic equal to 0, you got to deal with the base e. So the problem with that is e is transcendental, which means it has a non-repeating, non-terminating decimal. So you're going to have no choice but at some point to estimate the E. So I wouldn't do that until the very last step, right? So go ahead and set up the quadratic formula. The C would be the negative e to the fourth, right? So that would be at this step. Now, probably one of these solutions is excluded, so it's probably going to be the minus the square root, right? And then just double checking that was the case. All right, so the only solution would be the plus square root. And then if you can simplify this a little bit, that would be a good idea too. So notice what I did. I pulled out the 4, so the root 4, that's why the 2 is multiplied there. And then you can divide top and bottom by 2. Now this should just be plus. I put plus or minus without thinking about it, because we're only accepting the plus root solution since the minus root solution got excluded, because if you put it back in the original equation, it would cause an invalid domain. You can't have logs of negatives. All right, so you want to do this because E needs to be estimated. So when you express your solution, you give to the world the exact value. And then if someone wants to get a decimal, they get to decide how to estimate it. So you want to try to maintain as much accuracy as possible. All right, so again, maybe that's not an issue. I don't know. All right, then over here, same thing. We've got the quotient property. And so once we have our division in the log, then we can change it to the exponential. So 1/3 the base, -1's the exponent, which means that's the reciprocal. And then you can go ahead and put that equal to 3, cross multiply, and solve. And then 31, all these have the same base, even though you don't know what the number is, but they're all the same, letter A. Using the quotient property first, then you get the logs equal on both sides. So then you can reverse logging. And there's no problem cross multiplying here. If you got it equal to 0 and got your big fraction equal to 0, that's okay, but it'd probably be easier just to cross multiply. And then once you finish that, something cool happened. The x squared terms disappeared. And so this is linear. And then, of course, you do want to check to make sure that's not excluded, but it's positive. So if you look at the 3 original domain expressions, I'm sorry, 4 original domain expressions, there's no way that would become negative when you substitute x equals 9/4. Okay?